Hello there and welcome to this workshop on Pandas Challenge, day 8 of 30. My name is Valentine and I'll be your instructor. In this video, we're going to be going through a set of challenges in relation to Pandas, and these will be challenges that we've covered before in other challenges, as well as newer challenges that will be based on new concepts. So let's get started. Visit the link in the description. That's the practice resource link. It should take you to this page, and then click on the sample practice resource. Once you have done that, you should be able to get to this particular resource. If you're an Afterwork member, you can click on the practice notebook and you can have access from the practice notebook to just a lot of challenges that we have in store for you. So if you're just here and you just have access to the notebook, it's okay. But if you want more practice, consider the practice notebook, and you can always get it by just becoming a member. So to get started with this notebook, the first thing that we need to do, I will be using my practice notebook, but if you're using a sample notebook, you can click on File, then Save a Copy in Drive, and it should open a copy in the new page, in a new tab of in your browser. Once you have done that, you can then decide now to connect your notebook. So I'll just quickly, I won't create a copy of my practice note or of my notebook. I'll just open in playground mode, and this will ensure that my changes or the changes that I make are not saved. So once you have saved a copy, inside that copy, click on connect. Just click on connect. It should take a few seconds. All right, so we are connected. So the next thing that we need to do is to run the prerequisite. So we need to import the Pandas library as we've done in the past. Let's do that. Then once we have done that, the next thing that we need to do is now to go through now the concepts. Starting off, we'll get to learn about how to encode categorical variables with a label encoder. This is a technique that allows us to replace the values of categorical variables with the numerical representation. So it's important to do this because when we want to train machine learning models, we need to ensure that the data that we are training those models on is of a numerical nature, and data would come in either categorical variables, or it can also come in the form of which of course would hold textual data, but it can also come in numerical form where we have variables in numerical form. So there are many techniques to perform encoding, and encoding just means replacing those values with those values in categorical variables with a numerical equivalence. So there are many techniques, but using the label encoder is one of them. So let's load this data set. Once we have done that, we can be able to understand. You can see that from this data set, this is what we have, just the records pertaining to employees. Let me even just zoom in a bit so that we're good to go here. So we can see that we have numerical, we have records which represent employee IDs. Then after that, what we're going to do in the next section is to import the label encoder class and instantiate or create an instance of the label encoder, which we will use to transform or to perform that replacement of those categorical variables. So in our case here, let's say for gender, we have gender as we either have male and female values. So for label encoder, we apply, for gender, we apply the label encoder fit transform method, and we pass to it the gender column, which will give us the numerical representations of the categorical values that we have for the respective column. So for the gender column, we have as follows. So we also have for department, we do the same case for education, position, location, marital status, and also employee status. So these are pieces of data that they are categorical in nature, so we can apply the encoding technique, and then we display the updated data set that we have. So we should have the data set that contains numerical representation as shown. All right, pause the video and then work on the challenge. Moving on, aside from using the label encoder, another technique that we can use to perform encoding is usually the one-hot encoding technique. This allows us to convert the categorical variables into numerical representations, and we technically what we would do, instead of replacing integers with now the original values with some integer values, what we would do is to create what are called binary columns for each category. And yeah, so like for example, what we're going to see, let's say in our case here, we're going to load this data set. So this is what we have. In order, let's say, to create to perform one-hot encoding on the department column, but we can always perform on other columns, department column, job title, and location. We can use the get dummies function from Pandas and pass the data frame that we want to perform one-hot encoding. Then we pass the columns that we want to specify. If you don't, it will apply one-hot encoding technique to all the categorical variables that you have in the data set. And then we display that. So as you can see here, we have now a new data set that contains some new values, some new variables. So for department, finance, so for each and every value that we have for the categorical variable that we want to encode, we create a new column. Like in the department, excuse me, in the department column, we have finance, we have HR and IT, which are all values within the department column, but we create now columns to represent whether we have those values for those for the records that we have. So we do that. We can do that for all the categorical variables that we have. Right, pause the video and then work on the challenge. All right, moving on, discretization and binning. At times we might want to create a new categorical, not a categorical, yes, it could be a categorical variable, or a new variable that represents say, that groups a continuous numerical variable. Say for instance, if you have numerical variables in age, having values with a range from 1 to maybe 100, we could decide to create categories for those particular for that range. So we can decide to create what are called bins, which are just intervals. So we can decide to say that if you know, we can create maybe a bin that covers from 1 to maybe 10. That's a child. Then that's a bin. That's a child. Can name it that. Then from 10 to 20, can rename it teenager. Then 20 to 30, we can rename it whatever that we want. So we can be able to create what are called bins and use them to create newer variables that we might have. So for example, if we load this data set and we want to create maybe a new category for salary, so we would want to have a new variable called salary category that will contain either low, medium, high, and very high values. And the bins that we would have would be as shown. So from 0 to 60,000 would represent low, then 60,000 to 80,000 would represent medium, then 80,000 to 100,000 would represent high, 100,000 to 120,000 would represent very high. So in such a situation, we can be able to use that to create a new column, and that will contain the respective values, these values, the labels that you see here, based on the original values, that's a salary. So initially what we would need to do is to define the bins that we would use for discretization based on the salary distribution. So we would look at salary, the range of it, and we define the bins and also the labels, which would be as per the bins. Then once we have done that, we would then decide to use the Pandas cut function to be able to apply to or to create a new column that we want, that's in our case salary category. And essentially what happens is that we are able to get this new salary category that contains newer values for salaries based on the bins and labels that we had defined there. Then once we do that, we display the updated data set with the new salary category column as shown. All right, pause the video and then work on the challenge. In some cases, we might want to detect outliers within a data set, and this might involve just detecting outliers in single columns, so variable per variable. So we might want to determine whether in a particular variable, say for example salary, which is numerical in nature, there are outliers. So for instance, you can see that 675 and 80,000, there are this, you know, they differ significantly. Like this is way too large than you know, what we have here. And yeah, so we might want to determine those outliers. So we can use the z-score method to be able to perform that task. And what would happen when we use the z-score method is that we would measure how many standard deviations the different points are from the mean. So for example, we would get the z-score, which is just again a measure of how many standard deviations that point is from the mean. We would calculate the z-scores, and then we would have some sort of criteria or threshold and say that if a z-score is above maybe 3 or minus 3, then it means that that particular point is an outlier. So what we do now is, first of all, we calculate the mean and the standard deviation of the column that we want, which we do here. And then we can calculate the z-score, which is represented as shown using this formula. But again, you could also use packages that allow us to calculate the z-scores or z-scores. But here, this is just for ease of understanding and just breaking down what z-scores how z-scores would be calculated. So we take data salary minus mean salary, and then divide by standard deviation of the salary column that we want. And we have what will be on the far right is what we store in the z-score column, which would be a new column. Then we define a threshold. For us, we want to have the z-score to be greater than 3 or negative 3. Then we now get those records which have either a z-score greater than 3 or less than 3. And this is just Boolean indexing that we do here to just filter out records with a z-score greater than 3 or less than negative 3. And we display those outliers there. And we have one, which is the one that we had shown earlier. Pause the video and then work on the challenge. In some cases, we might want to perform sampling, and there are many sampling techniques that we can perform. We could perform random sampling, stratified sampling, cluster sampling, or even non-probability types of sampling, like snowball sampling, or other types of convenience sampling. There are quite a number of them. But when it comes to probability sampling, there's one technique that's called systematic sampling. And how this works is that you would get a population. Say, for example, if you have a population of 1,000 people and you want to get a sample of, say, how many people? Maybe 100 people. What you would need to do is to divide, say, 1,000 divide by the number of people that you want for in that particular sample. So we want 100 people. So we take 1,000 divide by 100, we get 10. So that would mean that in order to now select those people, we would use this value 10 as an interval to select the people. So we'd start, let's say, with the first person. We select the first person, and then we select the person who comes as the 10th person after the person who was selected. So the first person would be selected, then the 10th person, then the 20th, the 30th, 40th, and those people who have been selected would now end up becoming part of that sample. We can define also the starting point where we want to start. We can start at the first person or the second person, but again, this varies, and it also allows us to just be able to get a representative sample from a population. So assuming that this is our data set and we wanted to get records using this approach, systematic sampling, we can define the starting point, like the record that we want to start from, and the record that we want to in the interval. So this is it's called the sampling rate. So we will select every third row. So for example, once we have done that, before we even do that, we can then use the iloc method to define or to implement systematic sampling by first of all saying starting point 1, then double colon, 2 double colons, then the sampling rate. And we display the systematic sample as shown. So we start, we had defined our starting point as 1. So we'll be getting every third record. So after 1, 2, 3, then the 4th record, 5, 6, then the 7th one, 8, 9, then the 10th one, etc. So yeah, so that's how we're able to do that. And you can always change this. Maybe if you change this to 2, you'll be able to see that you still get different records. So we start from 2, then 5, 8, 11, etc. Right, pause the video and then work on the challenge. In some other cases, we might want to perform some data pre-processing tasks on textual data, and one of those tasks could be concatenating strings, combining strings into a single column. So we might decide to maybe combine first name and last name columns to create a full name column. And this might be important maybe in cases where we have reports which require that combined column. So let's load this data set, which we have first name and last name. And to combine both particular columns and create a new column, we first of all specify the name of the new column. Then on the right hand side, we set the operation that we want. We just use the additional operator, but on textual data, it means that we are able to bring those pieces of text together, but in between we want to have some space as shown. Yeah, and then we display the output. So we have full name, which will be created, and you will see it on the far right. Pause the video and then work on the challenge. We can convert categorical variables to categorical types. So for example, in our case here, we might have, so let me load this. And this is the data set that we have. And once we have loaded this, the next thing that we would need to do is to check the data types. So this is, by the way, this just involves being able to convert maybe a variable that might have maybe string data type to have now categorical data type. Initially you could have education, which might have object, which is a string data type. Like here you have gender, which is string, but to efficiently be able to work with these the data that you have here, we would need to assign them to a newer, a proper type of data type. So here we have these particular data types, and then to assign the category data type, which is what we can for categorical variables, we use the asType function and we pass the category value, and we apply that function to the column, the respective column that we want. On the right hand side, we just define the columns that we want to apply the changes to. So here, the values, this column will be applied to categorical variable, a category variable, and then we just make the change on that. Right. If you load this data set, you'll note that here we have objects, but if you load this, you should be able to see that now we have categories for the respective categorical variables. Pause the video and then work on the challenge. We can also create a box plot for outlier detection. Initially, we used z-scores or z-scores, but we can decide to visualize outliers. So, for example, in our case here, we are going to work with the salary column, the one that we had earlier. And if we wanted to display now outliers visually, we can use a box plot, which allows us to visualize the distribution of our points, like how spread the data is. So to create a box plot, we would use the plot function and apply it to the column that we want. And inside the function, we specify the type of plot using the kind parameter. Here we want a box plot. We specify the size of our plot, and we say that we want to display the outliers by specifying show flyers, and we assign it to true. If you run this, you should be able to see a box plot. and you should see it's a tiny box plot. If I change this to false, I don't want to visualize the outliers. I just want to work with the box plot. This is the box plot that I would get, but I want to see the outliers, which are points which are outside, the box plot. So you can see that there are outliers, two actually outliers within that column. The z-score method gave us one, but in our case here we have two, which means that we can investigate further. Like the z-score method can give us the value of this, and as well as we could adjust the z-score to be able to get the value or the record for this particular case, but we didn't do that. We could still do that, but I can leave it up to you. So that's how you create a box plot. Pause the video and then work on the challenge. We can also create new features. So this is just one of those techniques that we just learned. We've actually learned this technique in this particular categorical converting category, not converting, I think it was a string concatenation, where we combined two columns and created a new column. So it's the same concept that we're doing here. So we can create a new column called total spent out of two existing columns. So amount spent plus data, that plus income. If we combine the values of those columns, and we would get total spent. So if you load this data set first, we should be able to see that column. So we have amount spent and income. So that's what we can be able to see. But again, this, you can perform feature, it's called feature construction. It's part of feature engineering, one of the many feature engineering techniques. You can perform it, and it's usually dependent on whatever data set that you're working with. You might realize that you can create many features out of the existing ones. So if I run this, I should be able to see total spent as what I have on the far right. So if you see on the far right, you should have total spent. Pause the video and then work on the challenge. Lastly, we can decide to perform or to create a summary table and apply our own custom function instead of using the aggregate functions that we normally would work with, like sum, min, max, all those ones. We could decide to create our own custom function that leverages other functions or those functions. So as shown, so for example, in our case here, we have this data set. We might want to maybe create a summary table that contains department on the left-hand side, and on the right-hand side, we would want maybe two columns, maybe total salary and average salary. So you have maybe department, you have then total salary and average salary. So to be able to come up with those values for total salary and average salary, we can create a custom function. And what we're going to do is to pass to that particular function the group that we want. So this is, it will take in some group. And then we find the group is just basically the group that's a department that we want. And then we find the sum of the salary for that particular group. The same case with the average salary. And we give back what is shown here, which is just a Pandas series. It's more like a Pandas data frame, but now this one doesn't have a tabular structure. So it's in this particular data structure. Pandas series, that's what we return, and we pass now the outcome of this function to our apply function, which we apply to the group by output, or the table that we get here. So we'll get department. For each department, we'll have total salary and average salary. We apply the reset index function to just ensure that we have a Pandas data frame output. So if you run this, you should be able to get what we have here. We have department, total salary, then average salary, as you see here. Pause the video and then work on the challenge. All right, so that's it with regards to this challenge. If you did find it valuable, and if you'd want to tell us that we're doing a good job, be sure to give this video a thumbs up. If you would want to be informed when we post such future challenges, be sure to subscribe, and hopefully we'll be able to see you in a future video. All the best in your learning journey. Bye-bye.